Hello, and welcome to this course, BIM 101 for AEC professionals. This course is part of the Trimble Constructible series. My name is Michael Massey, and I'm excited to be presenting to you today. My goal is that after completing this course, you will have a better understanding about BIM and how it's being used today. Before we get started, let's put a face to my name. Here's a little bit about my background and expertise. I'm currently the Senior Manager of Innovation Services at Sanveo. I have 30 years experience in the AEC industry. I'm considered one of the leading experts for BIM VDC. I do have a degree in architecture from Texas A&M University, and I'm also a certified instructor with multiple professional certifications in Revit. So now that you know a little bit about me, let's get started. We will begin with BIM 101 to give you the basic understanding of what BIM is and why it's important. So what is BIM? BIM stands for Building Information Modeling. Let's start to define BIM by understanding what BIM is not. There's been a lot of misconceptions about what BIM is. First, BIM does not equal 3D. Many people think that if a project is done in 3D, that it is BIM. Modeling is just part of BIM, but does not equal BIM. Second, BIM does not equal data. Yes, it's true, the I in BIM stands for information, and there's a lot of information or data included in a BIM model, but BIM does not equal data. Next, if BIM does not equal 3D and it does not equal data, it must be the combination of 3D and data, right? No, BIM does not equal the combination of 3D and data. Finally, BIM does not equal Revit. I hear a lot of companies all the time refer to Revit as BIM. Revit is just a modeling tool that is used on a BIM project. A project can be done in Revit and not be a BIM project. Or a BIM project can be modeled using other software as well. One term that BIM does equal is VDC, or Virtual Design Construction. The term BIM and VDC are essentially interchangeable. Many on the design side of projects prefer the term BIM, while many on the construction side of projects prefer the term VDC. So now that we understand what BIM is not, here is a textbook definition for BIM. This is one of the first definitions that I ever saw about BIM. I originally saw this definition over 15 years ago. I know that there are many definitions out there, but this definition makes sense to me, so let's just read it. Building Information Modeling, or BIM, is the creation and use of coordinated, internally consistent, computable information about a project in design and construction. There are a lot of C words in this definition: coordinated, internally consistent, and computable information. Coordinated is referring to the trades that are typically coordinating with each other on BIM projects. They are looking for interferences and trying to make sure what they are installing is not interfering with other trades. So typically, on a BIM project is more coordinated than on non-BIM projects. Internally consistent refers to typically on a BIM project, the information for the project is coming from a single source, the model. The model contains all the data and information. For example, if a door schedule needs to be updated, you do not update the schedule. You update the model, which then automatically updates the schedule. So the model and the schedule are always in sync with each other. This makes a BIM project more internally consistent. Computable information refers to the fact that the model is not just dumb lines, arcs, and circles. It's intelligent modeling components that can be used for many analysis needs. The last part of this definition describes who is taking part in the BIM process. It's not just the designers. It's the entire project team. the designers, and the contractors. If I could change one part of this definition, I would add the word owners to it, because owners are beginning to drive the BIM on projects by making BIM requirements. The owners are the ones using the data in the BIM model for facility management when the construction is completed. So owners are very involved in the BIM process. If we take a look at traditional CAD for a second, we will see that traditional CAD is first of all focused on production drawings. Typically, when a project starts using traditional CAD, the team starts by saying, okay, we need a floor plan, an elevation, some sections, and so forth. They're more focused on the drawings as opposed to the design. Traditional CAD also typically has the project information stored in multiple files and formats, as opposed to all the information being stored in a single model. Traditional CAD also is difficult to manage changes late in the design. And finally, there's a risk of data loss during multiple discipline coordination. The traditional CAD documentation process consists of multiple drawings and drawing types. We have floor plans, elevations, sections, schedules, details, and maybe even a 3D model. All of these drawings are created in separate drawing files, and then they are placed onto sheets. This makes up the final documentation. When we compare that process to a BIM process, it's completely backwards. Instead of having separate drawing files, we have a single model. We develop the model, and out of the model we get our plans, elevations, sections, details, schedules, and the drawing set. This allows us the change it once, change it everywhere mentality. When we make changes to the model, it automatically updates the floor plans, sections, details, schedules, and our drawing set. With BIM, we do not have the problem of an element showing up in a schedule that has been deleted from the model. Once it's been deleted, it's deleted in all views of the project. The difference between a CAD process and a BIM process leads to a change in the way we approach projects. As I previously stated, the CAD process starts by thinking about the documentation, whereas the BIM process allows us to focus on the design, and the documentation is a byproduct. BIM requires a new way of thinking. To give us a better understanding of the importance of BIM, I want to introduce the McLeamy curve. This graph has been around for a long time, but it's a good tool to use to understand why BIM is needed. The bottom or horizontal part of this chart represents time. We have the different phases of a project: pre-design, schematic design, design development, construction documents, procurement, construction administration, and operation. The vertical leg of this chart represents the amount of effort or the amount of the effect we can have on a project. The first curve is indicating the ability to impact cost and functional capabilities. Early on in a project, changes can be made that will drastically have an effect on the cost or function of the project. For example, we can change the design from a multi-story building to a single-story building. As the project continues, we are not as likely to make drastic changes because we are too far along in the project. The second curve represents the cost of these design changes. As the project progresses, changes that are made will become more expensive. The third curve represents the traditional design process. Majority of the work is done on the project during the construction documentation phase. This is where designers are in crunch time. They will pull in extra people to get the project finished and out the door. But if we look at this is past the point in the project where we can make changes, or the cost of these changes will not be affordable. Which brings us to the last curve. This represents the preferred design process. It is pushing the bulk of the work back to an earlier stage of the project, which will allow for changes to be made that will affect both cost and function while the cost is not too much. This represents the BIM process. BIM allows the design to be focused at the beginning of the project, and it allows the majority of the work to be done prior to crunch time in the project. BIM is more than just a model. There are many ways that the model can be used to benefit the project. Here are just a few. Conflict resolution allows contractors to find clashes with trades prior to construction. Quantity takeoffs. The model provides exact quantities of all elements in the model. If items are added or removed, quantities are instantly updated. Simulation and analysis. There are many ways the model can be used in analysis tools, such as lighting analysis, airflow analysis, or even acoustical analysis. Context line of sight studies. Just being able to see or visualize the building. You know, civil and site designers are able to model entire cities, so being able to see the project in a larger context is critical. Facility management. Owners are taking the data from the model and plugging it into facility management software to operate the facility after construction is completed. And of course, construction documents and specifications. We are able to compile different views of the model onto sheets to make up our documentation. In addition to what we can get out of the model, the data we can input into the model is endless. Depending on what the model is going to be used for, we can populate the model with additional information. Here are some of the types of data that could be inputted depending on how it will be used downstream. BIM is so much more than just floor plans. This is where the I in BIM really comes to life, and the information is the key to the process. Now that we have a basic understanding of what BIM is, let's turn our attention to the BIM team. As I have previously stated, BIM is a process, and it's an approach of all the team players playing well together. Even though everybody on the project is trying to achieve the same goal, we sometimes don't end up where we should be. And when problems occur, we typically start the blame game and start pointing fingers at other trades. We just need to learn how to get along and play well together. If we look at the traditional relationship of the owner, architect, contractor, the owner has a contract with the architect, and the owner has a contract with the contractor. There is not a contract between the architect and the contractor. With contracts like this in place, the owner, architect, and contractor will put up barriers to protect themselves from being liable. As opposed to working together, they will be reluctant to share information and work as a team. This causes conflict and is not what is best for the project. A new type of relationship that's becoming more common on BIM projects. This is IPD, or Integrated Project Delivery. In an IPD agreement, instead of separate contracts between the owner and the architect and the owner and the contractor, there is one contract that binds all three parties into one team. The owner, architect, contractor all share responsibilities and all three share liability. If the project is successful, then all are successful. If the project is not successful, then all are not successful. This naturally encourages all to share information and play well together. This type of relationship is why BIM is being required more often by owners. Owners want successful projects, and this is a way to improve success. These two images are displaying how data or information is shared on a project. The image on the left represents a non-BIM project. We have lots of players involved on a project, and they're all trying to get information from other team members. As you can see, it is a jumbled mess, and there's no wonder why we have so many RFIs and change orders on a project. The image on the right is representing a BIM project. Now, it's exaggerated, but the point is still there. Instead of having to go to other team members to get information, one can go straight to the source, the BIM model. For example, if I'm an electrical contractor and I want to know the height of the ceiling for the lights, I don't need to call the architect. I can go to the model and see for myself exactly what the ceiling height is. Yes, there'll still be phone calls and RFIs, but on a BIM project the communication is simplified because everyone can get the information from the source, the model. Another huge issue on projects is the loss of knowledge as the project is passed along through the different phases. This chart is representing a typical project. From left to right are the different phases of a project: plan, bid, build, and operate. The amount of knowledge is indicated on the right from less to more. When a project begins, the design team does not know very much about the project. They know the vision that has been shared with them by the owner, and that's about it. As the design progresses, more and more knowledge is gained. By the time the project is ready to go out to bid, the designer understands and knows a lot about the project. When the project goes out to bid, there's a huge drop in knowledge loss. The estimators for the contractor have not been involved with the project, so they know nothing about the project. Yes, they have the construction documents, but that's it. But by the time they put their final bid numbers together, they know a lot about the project. They probably even know more than the designers. They have picked up on any mistakes or errors that may not have been noticed by the designers. Once the project begins construction, the estimators turn the project over to the contractor to build the project. Again, the contractor has not been involved in the project up until now, so their knowledge is limited. But they have the advantage of the construction documents and the notes and findings from the estimation. So they are starting at a higher level than the bidders. As they build the project, their knowledge about the project becomes very high. They not only know and understand the project, but they know they had to move something because it didn't fit, or they had to make this change due to the problems that were discovered. Once the project is completed, the contractor will hand the building over to the owner. The owner now has the benefit of a finished building as the starting point of his knowledge, but even with the building being completed, the owner does not know everything about the project. For example, the owner may not know what size air filters are required until they need to be replaced. As he operates the building, his knowledge continues to increase. This loss of knowledge is huge and can cost the project time and money. The goal would be to simplify or smooth out this curve so there's not such a drastic knowledge loss as the project is handed off to the next party. BIM tries to do this. It smooths out the curve. With all players being involved at an earlier phase of the project, the loss of knowledge is not as drastic. It allows the information to be passed on and to be continually gained by all parties. So that brings us to why BIM. Many people see BIM as a requirement or a burden. Let's take a look at why BIM is important and some benefits of using BIM. First, I want to make sure that I include civil engineering into this discussion. The building in BIM is misleading. While architects and engineers are focused on the structure in a BIM project, civil and site engineers use BIM to model and collaborate with railroads, roads, and bridges. BIM is becoming more and more critical for civil site engineers. As GPS machine control systems are being used more and more, This allows for the entire project to be geolocated and to automate tasks as equipment is being used with built-in GPS tracking. This allows for projects to be completed more accurately and faster, which improves the project and saves money for the project. Being able to have accurate information about utilities is critical. There are many existing and new utility lines on a site, and they should be coordinated just as everything else in the project. Visualization on the project is huge. Not only being able to visualize the building, but being able to visualize the building in the larger built environment. Civil site engineers can model entire city blocks. Knowing how the project sits in context of the property within the larger built environment is becoming more important. As far as benefits to contractors, there are lots of them. Probably the most common benefit is the ability to identify collisions and conflicts between trades. Just being able to visualize what is to be built is a huge benefit. Contractors are finding fewer errors and corrections are needed on a BIM project. Being able to open projects up to prefabrication allows for higher quality and lower cost. Being able to do more what-if scenarios is easier on a BIM project. The ability of non-technical people such as clients to visualize the end product. And contractors are seeing fewer callbacks on projects, which in turn lowers warranty cost. The Associated General Contractors, AGC, put out a Guide to BIM handbook. This handbook was produced many years ago, but is still being applied today. Here are some of the key points from the handbook. BIM adoption is accelerating. BIM is not going away. It's here to stay. Some think BIM is just a fad, but many people believe that if you do not get on board, you will be left behind. Many builders want models but prefer not to build them. There are a lot of contractors that do not have a BIM department or the personnel to create models. There are many ways for contractors to get involved with BIM. They can outsource or they can learn how to implement BIM. Contact me if you fall into this area. Owners are becoming more knowledgeable about BIM. Some have heard of it and they know that they should be asking for it, but they may not know exactly what it means. As owners become more educated, BIM will only increase. And finally, the benefits of BIM spreads across the entire project team. There are many myths about BIM. Here are several that are very common. Myth number 1. BIM is only for large projects with complex geometries. This is not true. BIM is being used on all types of projects today, regardless of the shape and or size. Myth number 2. BIM is only for large contractors who can afford the investment. Again, not true. Contractors of all sizes are seeing the benefits of using BIM. Contractors large and small are being left behind if they refuse to adopt BIM. Myth number 3. The whole project must be modeled in a single model. While it's true that one of the major benefits of BIM is that all the data is being contained in a single file, the fact is each trade is working in their own model, and then all the models are brought together to collaborate with the other trades to make a single collaborated model. I would like to wrap this session up by talking about some of the BIM tools that are available today. These are just some of the tools that are available today to assist you in your BIM journey. There are literally thousands of tools in different arenas that have been developed. This list is growing every day. Each of these tools have their purpose, and it is important to understand what tools you need and know how to use them correctly. Choosing the right tool is critical. These are all pictures of different types of brushes. Each brush was designed for a specific purpose. If I had a $1,000 suit with lint all over it, I would not use the scrub brush to try to remove the lint. I would use the lint brush. It's specifically designed to remove lint. Similar to BIM tools, I want to use the correct tool for the specific purpose that it is intended for. If I'm wanting to create a model, then I need a model creation tool. Not only that, but I would also need to know how to use the tool correctly. Here are the instructions on how to use a lint brush. I would want to make sure that I got the correct instructions for using BIM tools too. This can be done by ensuring that the proper training is provided with the tools to know how to use them correctly. This concludes the presentation on BIM 101 for AEC professionals. I hope that it was educational, and I hope that you have a better understanding of BIM and how it's being used today. On the screen is my contact information. Feel free to reach out to me if you have any questions and/or want more information. I want to thank you for joining this session, and I look forward to one day meeting you.